Hello everyone, welcome back to the part 3 of NSEP PYQs of the chapter Work Power Energy. Till now we have covered till question 10 of the chapter. So today we'll be covering from question 11 onwards. So question 11 says the formation of solid argon is due to van der Waals bonding. In this case, the potential energy as a function of interatomic separation can be written as the Leonard-Jones 612 potential energy, which is given as minus a r raised to the power minus 6 plus b r raised to the power minus 12, where a and b are constants. Given that a is equal to 8 into 10 raised to the power minus 77 and b is 1.12 multiplied by 10 raised to the power minus 133. So we need to find the bond length for solid argon. So this is a nice question which requires a bit of knowledge from chemistry. So the potential energy as a function of r is something like this. So first, since when the interatomic separation, which is on the x-axis, and potential energy is on the y-axis, so when the atoms are at infinite separation, so the potential energy is assumed to be zero between them. So at infinity, the potential energy will be zero. So something like this, the graph will be something like this. And as they come closer, the attraction between the particles increases and the chances of bond formation between the particles also increases, and bond formation stabilizes the molecule. So the potential energy will reach a minima somewhere and then it will start increasing again, because as the distance between the particles decreases beyond the bonding length at which the potential energy was minimum, repulsive forces start to dominate over attractive forces. So repulsive forces make the bonds weaker, and so the potential energy starts increasing, making the molecule less stable. So the graph is something like this, and the equation of this graph is this. So we need to find the bonding length, which is basically the r distance where the minima is occurring. Okay, so minima of this er function needs to be found out as a so we basically need to find out dE by dr at which point it is 0, right? First let us find the derivative. So it will be 6a r raised to power minus 7 and minus 12 b raised to power r b multiplied by r raised to the power minus 13 equal to 0. So taking this on the LHS, we will get a r minus 7 is equal to 2 b r raised to power minus 13. So we need to find r. So r raised to the power 6 will become 2b by a, which gives us the required r is 2b by a raised to the power 1 by 6. So if we put the value of b and a in this function, we will get the value of r, which gives us the bond length, because the bond length is the r at which minima of this er is occurring, right? So if we put b and a 2 multiplied by 1.12 raised to power minus 133 divided by 8 into 10 raised to power minus 77 raised to the power 1 by 6, and if you solve this, you will get the answer as 0.375 nanometer. So the next question is an easy question. It says that a gas expands from I to F along three paths indicated. So the work done along the three paths denoted by W1, W2 and W3. So we need to find the relationship between them. So we know that for PV graph, the work done is given as the area under the PV graph, right? So for path 3, the area will be maximum because the area will be this much. But for path 2, the area will be lesser than path 3 because the area will be this much only. And you can see that the red area is lesser than the blue area. For path 1, the area will be 0, so work done will be 0 because uh, this particle is not changing the volume. If there is no change in volume, then delta V will be 0, so work done will be 0, which gives us the answer as A. So the next question, question 13, is a 6-marker question from 2012. It is a nice question. A particle moves in one dimension in a conservative force field. The potential energy is depicted in the graph below. So we are given a graph where y-axis is potential energy and x-axis is the position of the particle. So if the particle starts to move from rest from point A, then. So the first option is saying that the speed is 0 at the points A and E. So let us analyze the first option. So if the speed of the particle, so since the particle is starting from rest from point A, so the kinetic energy at point A would be equal to 0, right? So total energy would be equal to the potential energy of point A, right? And total energy would be same at every point because energy is conserved, right? So since the potential energy of E is equal to potential energy A of the from the graph, potential energy of E is equal to potential energy of A from the graph, and that is also equal to total energy. So it means that at point E also the total energy is consisting only of potential energy and there should be no kinetic energy. So this implies that kinetic energy at E should be 0, right? Because total energy is consisting only of potential energy at point E. So the option A is correct, that the speed is 0 at points A and E, because at E also kinetic energy is 0, so velocity is 0. Okay, so now since the field is conservative, we are given that there is a conservative force field, and we know that force is given as minus dV by dx for conservative force field, right? We know this. So from here we will get that acceleration can be given as 1 by m times of minus dV by dx, right? So from here we will get that the acceleration will vanish wherever dV by dx is equal to 0, right? So dV by dx equals to 0 means that the slope of this graph should be equal to 0, which is only possible at BCD. And at A and E the slope is not 0, right? Because the slope is positive over here and negative over here. So acceleration cannot vanish at points A and E, so B option would be wrong. And option C is correct because at B, C and D the acceleration will vanish. Now analyzing option D, it says that the speed is maximum at the point D. Okay, so we know that total energy is equal to potential energy plus kinetic energy. So for the speed to be maximum, this implies that kinetic energy has to be maximum. And since this total energy is fixed, so this sum is consisting of potential energy and kinetic energy, and if kinetic energy has to be maximum, then potential energy has to be minimum. So potential energy is minimum at point B, right? So at point B, velocity will be maximum. So option D is wrong because at D, although it is a local minima, but it is not the global minima. So here the velocity or speed won't be maximum, right? So the correct answer of this question is A and C. This was a nice question. So question 14 is a conceptual question. So it says that when two ends of a spring are pulled apart, increasing its length, it produces force equal to kx at its ends. At a point 1/4 of its length from one end, the force is. Okay, so a spring is being pulled apart at both the ends and it produces a force equal to kx, right? At one of the ends, at both ends. So kx is in this direction. So we need to find a point, the force at a point 1/4 of its length from one end of the from one end. So somewhere over here, okay. So since nothing is given about the mass of the spring, we will take it to be massless. So F is equal to ma is Newton's law. So if a body is massless, if m is equal to 0, then the force must be approaching 0, right? Because if the force is not equal to 0, then to make it non-zero, the acceleration must be infinite, right? Acceleration is equal to F by m. So if m is equal to 0, division by 0 is not allowed. This must be an indeterminate form of 0 by 0. So force must be equal to 0 as well. So on any massless object, the force is equal to 0. That is a fact, that on any massless object, the force must be 0. So now let us analyze the spring. So let me draw an enlarged view, right? So on this particular point, the force is in this direction kx, right? And since this spring is massless, so if I take a small element here, so if this is being pulled here by kx, an equal and opposite force must be here kx, right? Since the force must be equal to 0, net force. So here it is kx. That means that if I take this element, so on this wall, we know that the kx is in this direction. So here kx must be here, right? Which basically implies that on every point, we can even take smaller points to prove that at every point, the force will be in this direction kx, right? So it does not matter that at which length we are analyzing, the force on every point will be kx. So the answer would be option C, 1 times kx, right? So the question 15 says that a cylindrical vessel filled with water is connected by a narrow pipe at its bottom to another identical empty vessel. Okay. So a cylindrical vessel, something like this, is filled with water and it is connected to an empty identical cylindrical vessel at the bottom. So this vessel is empty at the beginning. So option A says that potential energy of water is proportional to the square of the height of its level. Okay, so we know that potential energy is given by mass into gravity into height, right? So this whole water does not have a single height, right? So we can assume the mass of this water to be concentrated at the center of mass of this water, right? Because that is the concept of center of mass. Then whenever we have a distributed mass system, we can consider the total mass to be located at the center of mass, and then we can calculate various parameters, right? So mass of this water would be given by, so mass is density into volume, right? So density is constant and volume would be given by the area of the cross section multiplied by the height, right? So rho ah is the mass. So potential energy would be finally given by, this h is not the height of this water, this is the height of center of mass, right? Because the whole volume of water can be considered to be located at the center of mass. and center of mass would be located at the half of this height, right? H by 2. That is very intuitive. We can also derive it. So P would be rho A H G H by 2. So it is proportional to H square. So option A is correct. That potential energy is proportional to square of the height. Okay, so moving on to B part, it says that 3/4 of the potential energy is lost when the water flow stops. Okay, so let us see that what will be happening when the water will start flowing into this empty container. So water will flow until both the containers have the same height of water, right? It is a very common experiment that both the containers the height of water will become same. So let us find out what the height will be in each container, and since they are identical containers, the cross section would be A in both. And if initially the height is h, then by volume conservation, so volume would be conserved in the volume of water is conserved in both the vessels. So initially the water is only in container 1 and the volume is given by A multiplied by h, and finally the height becomes same in both the containers, so it would be A h1 plus A h1, right? Because height is same in both containers. So h1 would be half of this height, right? So final potential energy would be given by, so this would be twice of rho A h by 2 g h by 4, right? Because in every container the water is filled up to height h by 2 and the center's mass is now at h by 4 from the bottom. So this would be potential energy in one container, and we have multiplied it by 2 to find the potential energy in both. So this would be rho A h square g by 4. So initially it was rho A s square g by 2 and now it is half of that. So the change can be found out using this formula. So this has become 1/4. The change is 1/4, right? And so we have to find the fractional change. So P initial minus P final by P initial. So this comes out as 1 by 4 rho A h square g by half rho A s square g, which gives us half. So option B is wrong because it is saying 3 by 4, and option C is correct because half the potential energy is lost when the levels in both the vessel are same. Okay, so D part is a bit conceptual, that loss in potential energy is equal to the rise in thermal energy. This is correct because the energy is conserved in universe, so the energy that is being lost in the potential energy, we just found out how much energy is lost, that has to go somewhere and that will be released due to the viscous forces, the temperature increases of the surrounding. So this is also correct. So the correct answer is ACD. This was a nice question.